Okay, part 2. Give it all a shot. Hopefully it doesn't break apart. It gets a little sloppy because it vibrates a lot. Come around to the other side here to show you. Works a little better when it's not quite full speed. So I'll back it back down. The bulb. There's my big bulb. Oh, here it is. Ironically, this bulb tends to stay lit even though the sparks aren't happening because of some weird transient effect, or I think it's the actual arcing that's going on top there. My top brush has a bit of a gap in it, so it's there's a million little arcs going on down just to the ring. I'm going to get closer to that. Million little arcs going on there, and I think that's actually contributing to what is pulsing the coil, and that's why I get this. I get illumination on the bulb, and then I get shock waves when the arc does fire, and that's when we see the plasma out of the incandescent. No ground hooked up yet. Turn the lights back on. So there you have it. I think I'm going to rewire it now, and I'm going to put it more in the traditional fashion, where the wheel, the rotary controller, is going to be discharging the bank in parallel into the coil, because I know I'll get much more current to arc over, and it'll probably arc a lot better, and we'll get a lot better, more stable frequency out of it. So stay tuned for that video next. Bye. Look at that craftsmanship. Stick your tongue on it. Progress. Better than it was before. That's all that matters. Get some really wild, interesting effects building up in this circuit. Even when I didn't have that electrode coming from the output of the high side coming here, when it was just the 4-gauge coil, 2-wrap coil, and the condenser, it seemed like a lot more amperage, obviously probably because of the step down of the 2 wraps there, but it was, you didn't want to touch it with a light bulb because it jumped right through the light bulb at you. Let's see how else we can hook this up.